correlation with the market of 0.65. Similarly, the average stock has a standard deviation of 35%. So given the fact that correlation is less than perfect, there is some room for working the magic of diversification. In your final exam, there's going to be an essay question asking you to think about the role that correlation has in diversification. And for that question, I'm going to expect you to discuss in the following ways. Now, this is a graph that on the vertical axis has portfolio return, on the horizontal axis has the standard deviation of the portfolio. And so what we're going to consider are investments in stock A and B, and how the correlation coefficient, or rho, between the returns of stocks A and B impacts our ability to diversify. If we had 100% of our investment in stock B, its return would be equal to the return on stock B, and its standard deviation would be equal to the standard deviation of stock B. Alternatively, if we had 100% of our investment in stock A, then its return would be equal to the expected return on stock A, and its standard deviation would be equal to the standard deviation of stock A. But there's nothing to stop us from varying away from 100% in B or 100% in A. We could have any combination. And so what I want you to think about, is what happens to the return and standard deviation of the portfolio as a function of moving away from those proportions. And so first we're going to look at the case where the correlation between A and B is perfect positive. And only with perfect positive correlation do we find that both return to the portfolio and standard deviation of the portfolio are just weighted averages or linear combinations of the returns to the individual securities. And so by deviating from our 100% in B, we can be anywhere along this line, this red dotted line, as far as portfolio, return, and standard deviation. And only under perfect positive correlation are we unable to get rid of any risk through the process of diversification. We saw when we combined high-tech and collections that we were able to get rid of almost all risk by combining them in a portfolio because they were negatively correlated with each other. If two assets are perfectly negatively correlated with each other, in other words, they have a correlation coefficient of -1, there is going to be some way for us to weight those investments in the portfolio to end up with a standard deviation of 0. In other words, to perfectly diversify, get rid of all risk. However, deviating away from those low-risk weights, we can have return standard deviation combinations anywhere along this line or this line segment. Now remember, before we talked about the concept of stochastic dominance. In this case, any rational investor would prefer one of these line segments over the other. And it's the upper line segment that's preferred. where for any standard deviation you get a higher expected return. Now, most stocks are neither perfectly positively correlated with each other or perfectly negatively correlated with each other. So we're going to look at the third situation, and that's where the correlation coefficient is between +1 and -1. And by deviating from 100% in either A or B, we can have return standard deviation combinations anywhere along this backward bending red curve. The lower the correlation, the more the curve will bend backwards, until at its limit, at correlation coefficient of -1, we end up with the two line segments again. The horizontal distance between a point on the perfect correlation line and a point on the red curve for imperfect correlation is the amount of risk that's diversified away by combining the assets in a portfolio. So, there's going to be an essay question on the exam that asks you to explain how correlation impacts diversification, and I expect you to retell the story you just heard. Next, I want to talk about this, and that's how can we break risk down into its components. We can look at total risk, and that's standard deviation, as being the sum of two components, market risk and company-specific risk. Market risk are those kinds of events that, should they occur, are going to impact all companies in the economy to some extent or another. Things like war, natural disasters, inflation, supply shocks. Market risk is not diversifiable. Therefore, portfolio exposure to market risk is just a weighted average of the individual company's exposure to market risk. Company-specific risk, on the other hand, just impacts one company. They're the kinds of events that might have an impact on a particular company or its industry, but by and large don't affect other companies in the economy. These can be the negative things like strikes, natural disasters, lawsuits, product tampering, dangerous products, or the death of a key executive, or positive events like inventions and discoveries. Company-specific risk can be diversified away. And so there's going to be a second essay on the final exam that asks you to think about the impact that the number of securities has on diversification. And I'm going to expect you there to reproduce this graph that has standard deviation of the portfolio on the vertical axis and the number of securities on the portfolio on the horizontal axis. And so think, if we just have one stock in the portfolio standard deviation is going to equal the standard deviation of that stock, and that's an average of 35%. However, as we add more stocks to the portfolio, the standard deviation of the portfolio decreases. And what happens is the company-specific risk is reduced. Think of it. If we had 10 stocks in the portfolio, it's unlikely that all of those stocks would be getting bad news at the same time or good news at the same time. Some stocks are going to get bad news, some good news. The positive impact on return of the companies that got good news offsets the negative impact to those companies that get bad news, and portfolio risk or standard deviation is reduced. But there's a limit to this. Notice, by the time we get to 20 or 30 stocks in the portfolio, we have virtually eliminated all company-specific risk, and we're left with market risk, which is not diversifiable. The second part of the essay will be to ask you to think about this. Are there any additional benefits to diversification by including international stocks in the portfolio? And we can think about it in this way. If we have just U.S. stocks in the portfolio, we get the same blue line that we did before that's asymptotic to the U.S. market risk. However, the economies of foreign countries, although correlated with the U.S. economy, that correlation is not perfect. And so by adding some international stocks to the portfolio that previously just included U.S. stocks, we're able to even diversify away some exposure to U.S. market risk. Well, we've talked about expected return of individual securities and portfolios. We've talked about standard deviation of individual securities and portfolios and coefficient of variation. And in this lecture, we talked about diversification. From here, we're going to look at models, theoretical models that relate risk and return.